So at this point, now we have a velocity vector. So what do we do with it? Well, we apply it. We say object set linear velocity right out of our tool. Right out of our Corona toolkit, and we say vec x, vec y. That takes this vector that we calculated, we pointed it in the right direction, and we gave it a certain length, and now we're going to say that is your velocity, go. What we should see is when this runs, the bullet should take off, if I didn't mess up, should take off in the direction the target was at the time that it was pointing at it, which is the weakness of this, because the target will keep moving. Boom! Alright, set linear velocity. Oh, idiot. Sorry. Temp. That works better. Apply it to our bullet. Okay, we're firing and we are totally missing. Okay, so we're over time, but in the next 5 minutes we can fix this problem and always hit it. So let's do that. Let's change this example to make that bullet always go and smack that baby. Or at least cross it, because there's no body, it's not actually going to do anything. So I'm going to copy the project. I'm going to call this one homing. Thank you, Sergey. Projectile. Give him props, because props are due. And let's get this code out of here. Let's go ahead and load up this project. Homing projectile. It's going to do the same thing as our current one. Well, let's make it homing. The homing is saying, all right, cool. So it's got an initial velocity of whatever. I'm going to make it a little bit slower just for fun because I wanted to give it time to home. So I'm going to make it like 50, first of all. Now the bullets are going to come out, and they're going to be super slow. So what we need to do is we need to say every frame, you look at the target, determine a vector between yourself and the target, turn yourself, and move in that direction. So let's go ahead and add a function. I'm just going to put it right here for now, called steer. And then I'm going to say temp inner frame equals steer. Runtime add event listener frame, enter frame. I know you guys are probably just having a good old time with me not being able to type here. And then let's go ahead and say steer equals function self. And let's not fill it in yet. Let's just make sure that I always do this. So I put in the framework and just run it to make sure I didn't goof up. And I did. What did I goof up? 83. Run time add event listener. What did I mess up? Oh, idiot. That's how I code all day long. I constantly call myself an idiot all day long as I'm coding. That's letting you guys in a little secret there. Okay, I got 3 minutes left. Okay, so it's the same thing over and over. I mean, this is what I mean. You do this all the time. I mean, this is a little bit wasteful. The good thing to note is that the Math2D library comes with what is called a flexible variant of these, which is the one I'm using now. This flexible variant of these functions takes objects, and it also takes scalar values. So if you wanted to put the x and the y of the object and the x and the y, so 4 arguments, x1, y1, x2, y2, you could do that. And this function would recognize that you had changed the pattern of the signature of the function call, and it would do the right thing and say, oh, okay, you're passing me scalar values, numbers, versus a vector, an object, that encapsulates that information. Now, there's also a fast version of this incorporated in here, which is simply fast if, and it only takes scalar values. So it's less flexible, but it's as fast as possible. So this one will execute significantly faster than the flexible version, but depending on your usage, you may not care. it may not make a difference to your game. If you find you're using the Math2D library and part of your game is kind of slow, consider moving over to the fast version, and then if that doesn't work, then you need to break down that specific calculation and hand code it at the location you're doing it so that it's fast as possible. In other words, don't use my library, but actually do the vector math yourself, and that will be the fastest possible implementation of that calculation. So I'm just going to show this to you. Actually, you know what? I don't like these. I like the flexible versions so much more because they're smart in that if I pass 2 objects, they return an object. If I pass 4 numbers, they return 2 numbers because they say, well, that must be what you're thinking. And you can also tell them, no, I want you to take 2 objects, but I want you to return 2 numbers. So if you put the last argument to all the flexible ones as true, it returns the opposite of whatever you passed in. So if you pass in objects, you get 2 numbers. If you pass in 4 numbers for this particular call, you get an object or a table. So it's like very, as I called it, flexible. You can see this in the docs. It'll be a little bit more clear. Okay, so again, we want to steer this projectile in the direction of our target. So we need to know what that direction is. And the cheapest, simplest way to do this is simply to continually change the velocity of our object so that it's always moving in the direction that it thinks it needs to go. In other words, where the vector is pointing. So this thing that we just did here, let's just do it all again. And just take this, copy it down here, and I have the self argument here. So let's say self and self. And we'll keep it at the same velocity just for fun. And run it again. Boom, chakalaka. And now they're coming after it. Now, it's probably going to break down when it hits it, because it's never going to remove those projectiles. So that's a little goofy. But the point is at this point you can really see that it is in fact steering in the direction. Now let's make this significantly faster. Let's make this 150, 150, and let's make it only fire every 3 seconds, and so we don't get too many of these out here, and let's see what happens. Boom. Easy peasy. A naive approach to a homing projectile done in 4 lines of code. Yeah, 6 if you count these 2. Okay, 7 if you count the forward declaration. So, but the good news is if you don't like to type 7 lines of code, you could require the action library, and in 1 line of code, you would get the whole shebang, and you could even tell it how fast to steer. So, like, you could give it only steer at 90 degrees per second. So you can't steer that quickly, and you're lagging eventually, or depending on how fast your target's moving, you may lag it and have to turn one way and turn the other. You get cool little behaviors like our trails, which is what we do in our current game.
Well, this is great. I think this is a great example. Like you said, isolated from the game itself, so we can understand the different concepts.
Yes, I do hope that was a little more tractable. I think that people will watch this the first time, and don't feel bad if you're like, oh, it's still too fast. Just watch it one time, look at the code, go down and sort of like break it down the way I did, step by step, and see what comes out. You can go in here and print out the values that come out in the tables that are returned, and print those every frame, and you can kind of see what's happening. So, but not having to worry about all the other game going on and like breaking it, I think that'll make it easier for people to follow up on this.
Okay. Cool. So now, the action library, you said that's going to be available, or is available, or what was it?
The action library is currently in SSK, and if you want to look at it now, it's actually in the project. You just go into the SSK folder, and there's a folder under there called Actions, and it has a bunch of subscripts like move physics, move. I can't remember the names, but it's got all kinds of stuff for moving, using physics, not using physics, aiming, acquiring targets, etc., etc.
Okay. All right, and we'll link to everything in the show notes.
Yeah, I didn't want to go too much into what's in there. until I get the plugin release, because it's really hard for me to talk to it without documentation for people.
Oh, okay, and that's where I was thinking about is that last time you had mentioned that you're turning it into a plugin.
Yeah, it's just, it's done. It's just, writing the documentation is fun.
Right.
Fun.
Right. Okay.
I can't use Sergey's trick, which is just have 1 or 2 features on my plugins. That's all I have to document. Thanks for the advice, Sergey, but I just can't do it, dang it.
Just release 50 plugins, Ed.
Yeah, there we go. 1 for aiming, 1 for steering, 1 for moving forward. Oh my gosh.
Well, you could have a plugin system for your for the action library, right? The action library is like the core, and then you have plugins that plug into that.
There you go. I could do that for bonus dollars.
Yeah, exactly. Okay, well, cool. This is a great example. Thanks for putting all that together. So, where do you think we should go next? I know we talked about this a little bit before the show started.
We had a little chit chat before the show. Okay, so here's what I'm going to float. I think that next week should be the last episode on this game for a while, and what I would like to do is completely switch gears and convert from a fixed layout file method for creating the levels to a visual editor. So I will provide a visual editor, and I will demonstrate the fundamentals of how it's been. I'll show you where the code is and just give a quick walkthrough on the bits and pieces, and then show how to use it. And the reason I want to stop there is, and you can see me waving at the camera now, the reason I want to stop there is because I'm kind of getting, not bored, but I'm getting to the point where I want to take this game into another direction. And the direction I want to take it in is retain everything we've got, but make it a scene-to-scene game where it's a platformer that goes from scene to scene, allows you to navigate back and forth between the scenes, and it adds elements of a pseudo-RPG. So you can meet characters and get dialogues and get quests to pick up things, and you'll have not all at once, but we'll have dialogues, basic quests, inventory items, and an inventory screen to see what you've got, and whatever else comes out of that as we go along. I can't even think of the things. But basically what I want to do is sort of turn this into a pseudo-RPG/platformer, which is kind of the thing that I see a lot of people trying to do or have over time. And the questions come up. How do I do a dialogue system? How do I do an inventory? Et cetera, et cetera. How do I store what my character currently has between sessions?
Well, yeah, and then we kind of talked about this before, but yeah, making incremental changes at this point really isn't all that exciting. But going kind of and making some bigger changes, adding on these bigger elements, definitely sounds like something that would be interesting to look at and explore and see how the things are put together. So yeah, so great. Let's definitely do that. I know there were some votes for visual editor in the forums and stuff, and on the YouTube the comments and stuff. So that'll be great. Now next time, like I said, we're going to have Dean Murphy on with us. So that'll be I think a good episode for us to kind of wrap up this leg of the game and have him on as a guest.
Kind of a high level overview.
Yeah, right, exactly, and then prep us for the whole next series, and we'll have this game as a base, as a foundation for all these new features going forward, which will be great. I think it's a whole lot better than starting all over again. I wanted to comment on something
Barry said here. Sorry, before we hang up. Barry
there's lots of chat comments.
He said something about he called it extrapolating, but what you were thinking, I'm thinking, is predictive aiming, right?
Yeah, you basically extrapolate the position of where the target would be, and you aim at that instead. That's all.
Okay. I have in SSK. I'm not sure if it's currently released in SSK. It may be in my private copy, but I have a helper function that does that for first order calculation. So a first order calculation is where there's nothing is changing over time. So like linear velocity only, no gravity, no other outside forces are changing the direction. I can put that in as a third example when I commit this, if you want that.
I'm not sure if it's necessarily relevant. I mean, extrapolating is difficult to do well, and it still won't hit the target all of the times. So I think probably what people would want is much more like what you did anyway. I just assumed wrongly what you were going to start doing. That was all.
Oh yeah, no, there was no way it's very cool code, but it's like 50 to 100 lines of code to do that because it's calculus. So
Yeah, no worries.
So what I heard though is
calculus.
so, yeah, exactly. Calculus 1. Get your books out, kids. So what I heard is that there is a Super Starter Kit Ed edition out there someplace.
Oh yeah,
There's
a private version.
Nice, nice.
I don't release all my good stuff.
you
sounds really wrong.
You keep back the special marbles for yourself.
My secret sauce. That's
Yeah. Oh, that's fine too. Well, great. Well, we'll be back here next Monday, talk with Dean and wrap this portion of the game up. And until then, have a great week, guys, and happy coding.
Cheers.
Bye.
Well.